Cellular engineering, to me, as a biologist, is something very different than I thought it would be. As a biologist, I'm really thinking about how cells work. But thinking about how cells work as an engineer is something that I wasn't used to. So during this process of thinking about what cellular engineering is, has opened my eyes to sort of a different way to look at how cells work and what we can do with cells. So now I think about not just about proteins and things swimming around in a bag. Now I really think about what these kind of properties of those things within the bags have, and how that really determines what a cell does, how big it can get, or how small it is, or what it can produce.
The way I understand cellular engineering is that the cell, it has a massively complicated structure and has all sorts of different sizes and shapes of organelles. And it's not really clear to us in the scientific community how these organelles are built, because we know that the things that are building them, these proteins and molecules, are thousands of times smaller than the organelles themselves. So somehow these small structures are using just local interactions to create these massive structures. And we're starting to know a little bit about different kinds of ways they can do that, but we still don't have a fully complete picture. So I think, to me, cellular engineering means trying to understand that process better and learning how we can understand it and then in the future harness it to create cells that have desired effects, hence cellular engineering.
So to me, cellular engineering means being able to design cells with properties that we want. And so that's very kind of abstract, but I think of cells as little structures, little objects that contain objects within them. And they build those objects called organelles within themselves, sort of like we have organs inside our own bodies.
A cell is like one of the most complicated chemical systems that we can think of, and what cellular engineering allows us to do is to take advantage of the components of the cell that make different chemicals and actually engineer them to make what we want to make.
Cellular engineering is the concept of seeing the cell as a powerhouse that can be used and manipulated to create other products that we can use for commercial and medical ends. Because I remember personally, when I was first introduced to the concept of a cell, it was sold as this little factory that can be used to make things that has its own separate components. So right now, I'm specifically studying one component of the cell, which would equate to one component of a factory, and figuring out how to optimize it for future uses.
Cellular engineering is the ability to modify, genetically or otherwise, a species or a strain that we're working with to do something besides what it normally does. So for me, that means being able to modify a yeast cell or a yeast strain to produce things like insulin. So we can cause them to produce insulin, which they don't normally produce, and then we can extract that out, and we can give that to diabetics and improve their quality of life.
To me, bioengineering is the whole idea that you can take something that you don't have and provide to somebody that doesn't have it. So for instance, ligaments, if somebody doesn't have that, let's say somebody is paraplegic, what have you, like giving the ability to enhance life, that is bioengineering, that is cellular engineering.